Okay, heading over to Canvas. So as usual, there is an interactive version of the tutorial that I will be going through. But due to unforeseen technical difficulties, some of the plots are not rendering in here. So I'm going to be making the video from the local version that I have on my computer. And I will be making a static version, so kind of like a textbook version of it so that you can see all of the code in with all of the written explanations as well. So I'll also make that for the previous tutorials as well. So stay tuned and I will link that here along with the other sections. It'll be in a similar location. So apologies for that, but we will be working through that the best we can. So let's go ahead and get started with the interactive plots section. So in this section, we're going to learn how to extend our ggplot2 knowledge to make our plots interactive. So adding those interactive features, kind of like in Tableau. And this is going to be really effective for when we are at that final stage of an analysis, when it comes time to communicate this with our audience. And also it helps in the beginning of the process too. It allows us to explore our data more in depth and ask more questions and figure out more stories to tell about our data. So it's really helpful in the exploratory data analysis phase as well. So throughout the entire life cycle of a data visualization process, interactivity can provide value to our plots. We're also going to introduce some non-standard plots that we haven't necessarily seen before. So as far as the readings, this content is covered in a different textbook. That's not going to be a required reading for us. But if you want to read more, you can go here. And this is a book all about Shiny. So we'll be covering some random topics throughout several different chapters. So we'll have a lot of content to cover. And there's also the Plotly help documentation. That is going to be the main package that we're going to work with. Packages that we're going to need a lot of them. So go ahead and install all of these different packages. So Gapminder, Plotly is the main one, and then a few other kind of supporting packages to help us with some particular applications. So we'll need to have all of these installed if you're going to work through all of these videos. So here's the goal, is the end of this tutorial is we will cover these kind of advanced Plotly techniques where we have two things called two different interactive features called a highlight event and a filter event. So right now we are looking at house price data over time for cities in Texas. And with the interactive features, if I click on a city, it kind of dims all of the previous ones, all of the other ones, and just highlights the city that I'm looking at. So Fort Bend. I can also look at this dropdown and just select Amarillo, and it will highlight and dim the rest. So this is called a highlight event. So we're going to learn how to do this in Plotly. And then we can also learn how to do a filter event, which is a similar thing, except now when I click on Amarillo, it only shows me that data. So this is kind of like a filter event in Tableau. It's the same exact logic behind the scenes that's going on, is it's just looking at the data that I've selected, and I can bring up multiple. So if I want to compare Amarillo and Arlington, I can now look at Arlington's line and compare it to Amarillo's median house price over time. So we're going to learn how to do both of these by the end of this Plotly tutorial. So we're going to start with the very basics. So the easiest way to add interactivity to our plots is to just create a ggplot function, a ggplot plot like we have always done, and then just use the function ggplotly. So this allows us to translate our ggplot2 objects into Plotly objects, which adds that interactivity. The only thing that we need to do is save our ggplot object to a new object, and then call ggplotly on that new object. So let's demonstrate. So when I run this code, this just gives me a standard bar graph for the diamonds data set for the counts of different cuts. So following along with the written explanation here, All I need to do is save this to an object. So I'll call it P for plot. And then I just have to run ggplotly, which is from the plotly package, on that new object. And when I run that, the same plot, but now notice when I mouse over it, I get all these different features. So the interactivity, by default, it adds the kind of data labels when I mouse over each of the different bars. We can also zoom in on particular plots. Doesn't really helpful for this type of plot, but we can do it. We can just select certain areas to look at those. So there's a few different features that we can do with this interactivity. So next up is just demonstrating with the common plot types that we already know what interactivity is added when I use this ggplotly. So first up is going to be our standard side-by-side bar plot. So now when I run this with ggplotly, we get more features for the interactivity when I'm mapping to more aesthetics. So I still get the data labels, but now if I click on one of the colors, it makes it disappear. So I'm kind of isolating the non-clicked data sets, the non-clicked clarities in this case. So this is a great way to kind of focus in on particular aspects. And you just need to double click to reset. And maybe if I zoom in a little bit, that would help on these ones. So I can zoom in for some reason if I want to do that. I can click the reset axes. You can also download the plot. So a lot of neat features just by running this ggplotly. So let's take a look at how this affects our histograms. So here is my ggplot histogram, right? No interactive. And then when I call it to an object and run ggplotly, I now get the count for the specific prices for each of the different bars. So that is how the interactivity adds to our histograms. And the very last one, and this one was super useful with our box plots. So here is a box plot now by cut. Instead of looking at the count, we have a box plot. And it would be useful to know what these different values are. So what the medians are. Maybe there's a few outliers and I want to check what is the value of those outliers. That is where ggplotly comes in handy. So now when I mouse over, I get the values of that 5-number summary, and I can mouse over all of the different outliers. So I can see that the maximum is around 19,000 about, and I get all of these different outliers. So really, really useful for box plots. So here is an exercise for you to try. So the interactivity isn't always going to work perfectly with ggplotly. So pay attention to if it actually adds value to the plot for this exercise. So next up is some new kind of plots that we haven't seen before, or some new features of plots to help bring out some different features. So scatter plots. So one problem when you're working with big data and you're trying to make a scatter plot is overplotting. So this is when observations are kind of piled on top of each other, and it's impossible to tell if there's one observation at this particular XY, or if there's 100 points at that particular XY, right? That's the idea of overplotting. There's too much data in one particular region. One thing that we can do is use an alpha blending to make points semi-transparent. So first, let's take a look at my scatter plot. So right now, this is 50,000 data points, right? It's impossible to tell really how many data points are at each of these really, really dark areas. But if I add my alpha argument into my geom point, this is going to make some of the points transparent, and we're just looking at the darker areas. But still notice, right, it's so dark there, right? There's so much data. It still is kind of hard to tell with this alpha argument. So typically, I'd say rough guideline is this strategy works well when there is about 10,000 data points. So let's go ahead and just take a subset of our diamonds data set to show how this looks with that kind of maximum guideline. So if we change our data now to slice underscore sample, so now I'm going to take a sample from the diamonds data set, and I just want to get 10,000 points. Now this works really well. So I can kind of see there's clusters at particular log carats. So at particular values, maybe this is how we just measure carats of a diamond. And we can also see there's some gaps in the prices horizontally. So this is like the 10,000 guideline that kind of works well with alpha blending. And as far as the interactivity goes, when I run this with ggplotly, we should be able to get the XY of each individual point. So that's one strategy that we have for combating overplotting. Another strategy is to change our plot type and do what's called a hexagonal heat map, which does 2D bin counts. So essentially what we're doing is creating a heat map where each little section of our map is a histogram, and it colors it based on how much data is in that section. So let's take a look at our geom hex is what we have to do. So I'm going to change my geom point to geom hex, and we'll just run this static version. So this is what a hexagonal heat map looks like, is it colors the region of the data based on how much data is in that particular hexagon. So my lighter colors, that's when there is a lot more data compared to the darker regions. This is a great way to combat overplotting. So now I'm not just looking at 10,000 data points. I'm looking at the entire 50,000, the entire data set, and I can still get a readable plot. And this is kind of working with, in the background, the fill aesthetic in order to color those data points. We can also control how many bins are made. So if I were to add the argument bins equals 100 and run this, now they are finer bins. So now we get to see how at those particular carat amounts that there is more data with those vertical lightly colored lines. And as far as the interactivity goes, what we can do is again save it to an object called P and then run ggplotly on P. And this gives us the count at each of these different histograms, at each of these different hexagons, excuse me. So very, very neat plot for big data. And we really see how there's this gap here at this particular price. So when we use ggplotly, it can be great for plots like this because this will be a really hard plot to make when we are trying to do this kind of from scratch with plotly commands that we're going to learn next by themselves. So ggplotly is going to be great for these kind of complex plots that ggplot already has a lot of features, a lot of functions built into it, that we can then take those and just add that extra command of ggplotly and add some interactivity for it. So that's going to be a great, easy way to introduce interactive features into some really neat ggplots. Another example, a very common application of something that is built out very well in ggplot is when we're comparing groups across numerical summaries. So when we are kind of comparing group-wise analyses, ggplotly is going to be very useful. So one thing that we can do is make a frequency polygram, a frequency polygon plot, which is going to look like a density plot, just with straight lines rather than a smooth curve. So to make the static version of this, we can do ggplot data equals diamonds. And my AES, I'll do x equals price And I'm going to have multiple lines, so I want to change the color of each of them by the different clarity. And then we will add geom freak poly. And here's what this looks like. So this looks like our density curves, but now just frequency polygons rather than smooth curves. And I could, again, change this to density and we get a similar type of graph. But as far as the interactivity goes, I can change this slightly. So again, just saving it to an object and running ggplotly. Now I can isolate a few different clarities really well and just focus on the specific comparisons that I want. So a really neat way to kind of focus and narrow in on the groups that we are interested in. With really easy code, just running one extra function. So next up is an application. So when does this ggplotly come into play? Like what is another useful application for it? So to do this, we are going to demonstrate with the Gapminder dataset. So we went through a long example of merging the Gapminder separate datasets. There's actually a Gapminder package which kind of already has this built out for us. So we are going to take advantage of that for this tutorial. So the Gapminder package and the Gapminder dataset looks like this. We have our country, our continent, the year, the life expectancy, the population, and the GDP per capita. And this is already in long data format. So we have a row for every single year for each country. So we are going to create the standard Gapminder data plot and build a bubble plot of the GDP by life expectancy, and then we're going to add some interactivity. So bubble plot, to do that, let's just focus on the most recent year of data. So Gapminder recent is what I'll call it. And we're just going to look at the latest year of data. So filter year equals max year, right? So filter is going to just filter to specific rows based on the condition that the year is equal to the maximum value of year. So this is going to give me the most recent year of data. Then for my static plot, we can do ggplot. Data equals Gapminder recent. And then for our AES, we need our X to be GDP per cap. We want the Y to be life expectancy. And then in order to turn this into a bubble plot, we're going to use the size aesthetic. So size is equal to population. And when you're kind of working with multiple dimensions, we want to be careful of how we do that. So we want to really be sure that size is the correct way to incorporate this third dimension. So we've made this plot lots of times, so we know it's going to work out well, but that is a consideration that we have to take into account in other scenarios. And then we also want to color our plots, our points by the continent. And then we need to turn this into a scatter plot with our geom point. So when we run this, here is our Gapminder plot for the most recent year, which I don't currently know what that is. If I were to just run the data, looks like the most recent year is 2007. So this plot gives me 2007 data for Gapminder, colored by continent and sized by the population. So let's actually do a few things to clean up the static plot before we add that interactivity. So one thing to notice is that these scales here are kind of hard to read, right? There's no commas in here. They are really, really, really big numbers. So what can we do to make this more readable for our audience? The first thing that we can do is add commas. So just work with the output. So work with the representation of these numbers. So the way we're going to do that is with scale x continuous. And we're going to change the labels. And we're actually going to use a new function from the scales package. So when I do, I'm setting the scales for my x. It's a continuous scale, right? Numeric variable. I'm changing the labels attribute of it. And I'm calling the comma function from the scales package. And that should be all we have to do. And when I do that, I now get a comma in my values here. So pretty neat. We can do the same thing for the population. So now instead of scale x continuous, I'm going to do scale size continuous. And that should add commas into the population values. But notice these are really, really big numbers still. So maybe in context, we can turn this into millions, right? It's common to talk about population in terms of millions. So let's divide our population in the AES statement by a million. And now we get 250 million, 500 million, 1,000 million, which is a billion, and so on. So next up is to add some labels. So every plot that we make, we need to have a nice title. The title is equal to Gatminder 2007. And then we'll give an X equals a more readable label, so GDP per capita. This is in dollars. Y is equal to life expectancy in years. Size is equal to, with that new change, population in millions. So letting our audience know the units. And then color, we can just clean up the capitalization, continent. And then we can give it a nice theme. Theme BW. There we go. So now we have a much cleaner plot, a much more readable plot, a user-friendly version of it. So this would be a great final representation. But I also want to show you a very cool kind of data-driven trick. If, for example, I don't want to hard code this 2007 in there. So there's actually a way to get R to kind of process the maximum year and output that in the title for us kind of dynamically. So if my data changes, let's say I'm looking at the minimum year, it then automatically updates. So let's show you how to do that. So what we need to do is do year is equal to unique Gatminder recent $year. So all this is doing is it's looking at my recent data and it's pulling out the single value for the year. So that's all that does. So this year value is going to host 2007. Then what we need to do is modify our title. And what we need to do is use the function bQuote. So bQuote allows us to add data-driven features into our titles. So we can add in the constant, which is Gatminder. So the constant is going to go in commas. Then we're going to concatenate it. So combine it, we use an asterisk. And to evaluate a value, we wrap it in parentheses and put a period before it. So it's going to evaluate the value that year hosts. So it's going to take year, which is 2007, evaluate that, and concatenate it onto the string. So now, when I run this, I should still get Gatminder 2007. So now let's say I change this to the minimum year, and it should be like 1950 something. When I run this, now it changes to 1952, and I don't have to hard code that. So that's a very neat feature, right? Eliminates some need for copy and paste and just a bit safer way to create this plot title. So let's go ahead and add some interactivity now. So let's change this back to the maximum and save this as P. And we'll do ggplotly on P. So one thing to know is that this B quote feature doesn't work with ggplotly. So I'm going to change this back to hard-coded version with the 2007. Gatminder 2007. When you're working with new things, you always find some random reasons why things can't work, sometimes unavoidable. So now when I run this, here's the interactivity that I get. So I get each of the GDP, I get the X, I get the Y, I get the population, and I get the continent. But notice that I don't get the country, right? That's kind of important information for this, but I don't get that by default with ggplotly. So what's going on there is by default, the only interactive info, right, the mouse over text that we get is what went into the aesthetics of geom_point. So right now it's just the X, the Y, the size, and the color. So what we can do is kind of trick ggplotly, and we can add in a label aesthetic equals country. So this one is kind of unused aesthetic by the plot, so it kind of just gets ignored. But when we run this, the mouse over text now includes the country. So it's kind of a hacky way to get that label that we want. But let's say that we didn't want to also show the life expectancy in the GDP per cap, or we wanted to better format the population, right? These are the customizations that are going to be hard to do with ggplotly. So instead, what we're going to learn next is how we can rebuild this plot from scratch using kind of base plotly functions. So we will pick up with that in the next video.